So the Desmos activity is comparing arithmetic sequence, which is which function? Linear, versus geometric sequence, which is exponential. So you have all these different formulas. Why do they look so different? Because there's two different functions, right? Arithmetic and geometric, but then there's also two different what? There's two different formulas. Good. So look at this one. What does this one have to do with? It should be easy to identify. Yeah, this one's exponential. Why? It has an exponent, right? So everybody agree it's exponential because it has an exponent? What about this one? Is it exponential? Why? Because it doesn't have an exponent. Plus, doesn't it look like a linear equation? The mx plus b? Okay, what about this one? What do you think this one is? Exponential because it has a exponent. Good. What about, let's see, what about this one? Linear because it's adding and it doesn't have an exponent. So this one is what? Subtracting and no exponent. What about this one? Look closely. Is the n an exponent? Yeah, the n is the exponent, so it's going to be exponential. This one right here. So we have all of these, and I'm not connecting them yet because I'm just trying to identify which one is exponential and which one is linear. So all of these, look at these. There are no sequences. It's only arithmetic and what? Geometric, which has to do with which two functions? Linear and exponential. Are any of the sequences quadratic? No. So now look closely at these. Is this a subscript or exponent? Subscript. Is that the same thing as an exponent? No. What about this one? Subscript. This one? Subscript. This one? Subscript. This one? Subscript. So what we have to do is we have to look at the formulas that I gave you guys before. So where do we have subscripts? What formula? The explicit formula or the recursive? Okay, look at the subscript. So recursive is with the subscripts, right? At the bottom. All right, so now we have a subscript at the bottom and this is being multiplied, right? If we have a subscript at the bottom and it's being added or subtracted, what kind of sequence is it? Arithmetic. Okay, so I'm going to go back. So now what is this one? If there's a subscript and I'm adding or subtracting, what is it? Linear. If there's a subscript right here, right? And I'm adding or subtracting, what is that? Linear. Good. What about this one? So everybody look up here. This is going to be exponential. Why? It's multiplying and there's a subscript, right? What about this one? Also exponential because you have a subscript and then it's multiplying. Exponential because you have a subscript and it's multiplying. So the way that I organize them, I'm not Julie, I'm not Matt, I'm Miss Bolin, so I just organize them like how I would organize them. I know you guys all organize them a different way, which is fine, but you guys definitely need to know the difference between this was exponential and this was linear. So what did you guys learn from how I just organized them versus what I have already given you? What I have already given you was the formulas, right? Okay, so you already knew that if it's exponential, so you want to add to your notes. It's exponential if you have a what? What do all these cards have in common? No, look at all these cards. Yes, good job, Aiden. Exponential or exponent. If it has an exponent, it's what? Exponential. Add that to your notes. All right, the next one. What about all these? But there was something important. Subscripts. So put if the subscripts are being what? Multiplied, then it's what? Recursive exponential. Good. So if the subscripts are being multiplied, then it is exponential. Make sure you write that down. So all that pile on the left is exponential. Okay, with linear. What do all of these have in common? They're adding or subtracting. They're also in the form, look. So all of these with linear, all of these are in the form linear. They're all in the form y equals, or it's not y equals, a sub n is the same as y. So y equals mx plus b, right? Do you guys see that? Because the n is the x, so mx plus b. So they look like linear equations. Are there exponents? No. What about these? I have subscripts. Yeah, the recursive part, the subscripts are doing what? Are being what? Are being added. Or it can be what? Subtracted. That's why you need to be writing this down. So linear, if the equations are all in the form of mx plus b, then they're linear, right? Linear slash arithmetic sequence. If the subscripts are being added or subtracted, then it's also linear arithmetic. If it's exponential, or what's another word for saying exponential? What sequence? So geometric, if what? If the subscripts are being multiplied, see how the subscripts right here are being multiplied, or the exponent is inside the equation. You see that? And then I just had all of my pictures together. So I have all my exponential slash geometric pictures together. I have all my linear slash arithmetic pictures together, or I'm sorry, equations together. All of these are pictures, but they're pictures of geometric or arithmetic sequences. So how do you tell, like this one, the rubber ducky one, how would I be able to tell which one that belongs to? Does it belong to exponential or arithmetic? Why? How do you know it's being multiplied by 4? Yeah, so there's 4 rubber duckies, then 16 rubber duckies, then 64 rubber duckies, right? So this would be exponential because it's being what? Multiplied, right? All right, let's look at this one. This one, it goes from 1 square to how many? 5. So 1, 5, and then what? 25. So if you have 1, 5, 25, which? So what is that? Exponential. So you're multiplying by 5. What about this one? And you have to be careful because this is weird and it's also 3D. So 3, 6, 9. This is 12. And then this is 6. So 3, 6, 12. So times 2, where does this go? Exponential. And then this one, how many? Because we have 1, 3, 5. Yeah, 5 and 7. Where does that go? 1, 3, 5, 7. Why is it linear? Because plus 2, right? Because we're adding 2 each time. If you were multiplying, where would it go? Exponential. Good. What about this one? This is 5 plus 4, and then plus 4 again. So where does this go? Linear. So in the pictures, if they're being added or subtracted, it's what? Linear. Yeah. And in the pictures, if they're being multiplied, it's exponential or geometric. So exponential, geometric, right? That's the same, or linear arithmetic, and that's the same. So that's what you have to know. You have to know each formula, and you have to know what you like, how you can pick out which formula to use. Look at these cards again right here. How do you know which part is the rate that you're being multiplied by? So this has 2 numbers. How do I know which one's the rate? The one that the exponent is attached to, right? See, the exponent is attached to 4 right here. That's the rate. It's attached to 2 right here. That's the rate. It's attached to 5 right here. That's the rate. Down here. So the rate is just going to be that last number. How do you figure out what the first term is right here? 1, the first term is 1 right here, right? Because you don't see a number. What about the first term here? What's the first number? 3. What about here? This is 1 because there's no number, right? So what's the first term here? It tells you a sub 1 is what? 3. A sub 1 is what? A sub 1 is what? 4. Okay, it tells you what it is. Where? Because this is the rate. That's not where it starts. If there's not another number, it's a 1, and it starts at 1. What about these two? If it doesn't say, where does this start? The last number. Look, last number. So this starts, this is the opposite of what you think. So if it's linear, it says -1. So it starts at -1. This one says +1, so it starts at 1. This one says -2, so it starts at -2, because those are your y-intercepts. And the rate is whatever's attached to n. That's what you guys need to know. Yeah, y = mx + b, where m is the rate and then b is where you start.